All right, we're going to look at the third worksheet, which is bone physiology here, and we start out with this little table, and it's asking you for the function and the location. And let me move this out of the way. Well, hold on. Let's just look at this table for a second. The first thing I'm going to look at here is compact bone. So two of these are compact bone. The other, in the endosteum, is connective tissue, and the epiphyseal plate is made of cartilage. So these are different. These are made of compact bone. So we're going to look at these two first. What I'm going to do is I've located them in the textbook. So remember, you can download the textbook. It's a giant PDF. And if you search for compact bone or Haversian layer or something like that, or canal, you're going to find this particular topic. And I'm going to go here on page 202, and you're going to learn some things, and I'm going to give you some hints on the test too, which I've done in class, but we'll go through them here a little more. But know that there are two types of bone, compact and spongy. You need to know that. And of course, the compact bone is exactly that: more compact, more dense. That's the way you should think of it. So compact bone, right here, it says denser and stronger of the two bone types. And we go down here, and we have this picture. All right, so the thing we're looking for is the canal, the Haversian canal. Now, where is this thing? All right, well, you know, they don't do a good job of putting a label on it here, but it is in here, and here they have central canal. All right, so maybe that's it, or here is the perforating canal. Could that be it? All right, well, let's move on here, and let's go down here and see where they talk about it. And it says running down the center of each osteon is the central canal or Haversian canal. So the central canal is the Haversian canal. So let's go back and find it again. Where it's the central canal, it is this here. It's the center of these rings, and these rings are called osteons. So these osteons are these circularly, kind of like rings of a tree almost, and in the center of those are the Haversian canals, and you'll notice what they have. Each of them has, they have blood vessels, they have lymphatic vessels, and they have a nerve. So blood vessels, of course, arteries, veins, that sort of thing. Then they have lymphatic vessels. All right, the lymph I talked about briefly one day in class. We don't need to know it here, but know that there is lymph in there, and then a nerve. All right, so all of these things are what are in the center of these rings called osteons, and you need to know that. And of course, this is in what kind of bone? Compact bone. And then, of course, we go up here, and it says compact and spongy bone. So remember, this is compact bone, not spongy bone. All right, compact bone looks like little tree rings all grouped together, and then in the middle you have what? You have blood vessels, lymph vessels, and nerves, and that is called the central canal or the Haversian. So what is its function, and where is its location? Well, its location is in the center of the osteon. That's fine. You would maybe say in compact bone, but if you're talking about osteons, you're talking about compact bone, but you might say that. And then, of course, the blood vessels, lymphatic vessels, and that's what they hold. They have those things. So that is their function, kind of to provide blood and, in the case of lymph, waste removal, and of course, nerve is for sensory data. So all of that is here in the in this one little sentence here, one little paragraph. You can get all the ideas you need. You need to know what an osteon is, or the Haversian system. All right, and this is the microscopic view of a bone, of a what? A compact bone. Now, at the end of a long bone like this is a long bone. The center part is the compact bone here, or not the center part, but this more rigid area around the outside is going to be your compact bone. Now, at the ends, here you're going to find the term skip isn't coming into my head, but at the ends you're going to get spongy bone. Spongy bone is going to be different. It's not going to be like this, okay? Understand that. So let's look back at our question. The location and the function we now know for the Aversian canal. The other thing we were looking for down here is the compact bone. So let's, the canaliculi. Canaliculi, I always say it wrong. I say a lot of things wrong. But canaliculi, let's find that. All right, now where is the canaliculi? All right, now here we go. These are openings on the surface. All right, so let's kind of look through here and see if we can find where it talks about these openings on the surface. All right, trabeculae was the term I was actually looking for just a second ago. Let's see. Where do we have it? We have the caniculi openings on the surface, but where do we have a discussion of what they do? Let's see. Nope, that's cartilage, so we've gone too far. So let's see. Canaliculi. Spongy bone. Openings on the surface, compact bone. That might be here. Open out. Spongy bones come with trabeculae, osteocytes. Red marrow fills the spaces in some bones. So let's find caniculi. Should be in here. Right angles to the osteum. Microscopic unit. Calcify, running down. Spaces curl. Here we go. As described earlier, I guess we needed to look earlier. Caniculi connect with the of other lacunae and eventually with the central canal. This system allows the nutrients to be transported to the osteocytes and waste to be removed. So there you go. All right, it's part of this system. The caniculi are essentially passageways for the removal of wastes and the transport of nutrients. All right, so you have to read through there to get all of that, but that would be the answer we would be looking for. All right. Oh, here we go. So, like osteoblasts, osteocytes lack mitotic activity. They don't divide. All right, they're not necessarily growing in the normal sense of cell division. They can communicate with each other and receive nutrients via cytoplasmic processes and extend through the caniculi channels within the bone marrow. So those openings allow the communication, the receiving and transporting of nutrients, which makes complete sense. All right, between what? Between the osteoblasts and osteocytes. They lack, but they can communicate. So that would be true of osteoblasts and osteocytes. They can communicate with each other and feed nutrients. So right there is your answer of canaliculi. Canaliculi, yeah. All right, and that's going to be in compact bone. Now the others, so function and location right here in these sentences. Now the endosteum and the epiphyseal plate are going to be in cartilage and connective tissue. So we're going to have to go a little further down here to find those. All right. Cartilage templates, connective. So we're going to find the function of the epiphyseal plate and the endosteum. So we're going to need to find those things. And let's see. Now the easiest I know we're close here, but the easiest thing when you're searching the book is to use the actual search. You can go to edit and you can go to find. It depends on the software you have, but a lot of them have a search for it. So I'm going to go endosteum and just search the book down here, as you can see if you're following along. And there we go. Of the endosteum created internal callus. So here is our first location of that. So let's see, and that's going to be in bone repair from the endosteum. So it says that's the first time they use that term, but I bet it's in a picture somewhere up above. Well, that's where we were. Epiphyseal plate, epiphysis. By the way, this is stuff you need to know for the test, modeling and remodeling. Let's see if we can find endosteum. No. Let's see if there's a next. I'm going to go here. I'm going to edit. And it says find next. All right. A delicate membranous lining of a bone's medullary cavity. All right. So right there, that's telling you that what is it? It's a type of connective tissue. And what does it do? It's the lining of the bone's medullary cavity. So usually a membrane or something like that is going to have some function of either protection, or it's going to be resistance. Connective tissue could also be something like related to tendons or ligaments. So one of those two things is going to be the what do you want to call it? The function of this. So let's go see if we can find a picture, which is what I really want, is I want to find a picture of the endosteum. And I did not find that before, so let's go edit, and I'm going to go find previous, which will send us back up here. And where did it say it was? Let's go back. Find next. Said it was medullary cavity, so we need to find the medullary cavity, and that's going to tell us kind of what its function is. So if I go back here, and let's see, we need the medullary cavity. And I do not see this right away. So we do another search. All right, and we go medullary cavity. All right, so here we go. The bone breaks, blood flows. These vessels could be in the periosteum, osteons, or medullary cavity. The blood begins to clot about 6 to 8 hours after the fracture. All right, so where is the medullary cavity? Now, it gives us this thing, but it doesn't define it for us. So this is something in the medullary cavity. So let's do this again, and let's go find next. It's going to do this. All right, here's medullary cavity, and then we're going to find the next one after that. And it's a hollow region of the diaphysis filled with yellow marrow. So in other words, what is the, let's go back, previous, inside the diaphysis, this is the membrane inside the diaphysis. So let's go find the diaphysis. Alright, so we have the diaphysis. Nope, they're not going to give it to us here. Not up here, it's previous. We've seen that. I know I've seen that on a picture since we were... Right, there we go. The diaphysis is this region of the long bone. So basically inside there's a cavity and there's a membrane on the inside of that. And that is probably not going to be connective tissue for what? For pulling a tendon or anything. This is inside the diaphysis. all right, inside the hollow region there. So it's going to be something that's protecting the internal yellow marrow. But just in case, let's get online and let's search for this. All right, so we can ask ourselves what is the function of the endosteum, just to see what Google will say. Kind of know what it is and where it is, but what is the function? All right. Responsible for balance in bone deposition or resorption. Bone resorption is often greater than bone deposition, thus in the marrow. So that's the endosteum. All right. So what is its function actually? It's a connective tissue. All right. But is it actually what do you want to call it? It's a membrane, it's layers, but what do those layers do? They are responsible for the deposition and reabsorption of the bone. In other words, the bone is dynamic, and these two layers, which make up the endosteum, all right, are the ones, one side basically breaks down bone and the other one creates new bone. So that would be your function. And the location, of course, we kind of found. So let's go back to our search. All right, so let's go to, we know that it's what? It's here in the diaphysis. Let's see, the endosteum. All right, and let's see, let's go find the next. All right, delicate membrane lining of the bone's medullary cavity. Well, it's a membrane, all right, but it's got two layers, and one layer creates bone and one layer destroys bone. So realize that your bone is constantly being created and destroyed. It is dynamic, and that's what they mean by that. And so that's what that's trying to get to there. If you said anything kind of like that, you got that one right. All right, now let's go to the epiphyseal plate. All right, so in fact, that should be right here somewhere. Epiphyseal line, epiphyseal plate. All right, the sheet of hyaline cartilage and the near metaphysis of an immature bone replaced by bone tissue as the organ grows in length. So this is a plate that's kind of the barrier between old bone and new bone, or immature bone and mature bone. Of course, the mature bone is the compact bone. And so as you grow, your bones become harder, and at some point there's going to be a point where you have this plate that is going to transition from one type of bone to the other, and that's the epiphyseal plate, also called the growth plate. So in other words, if your bones are still growing, the growth plates have not all solidified into compact bone. And some bones continue to grow later in life. Some do not, and some quit growing very quickly. But as long as you have what it's called a growth plate or the epiphyseal plate, your bones can continue to grow. Now that is different from being reorganized or changed. In other words, that's different from what we were just talking about with the endosteum, where you create new bone and destroy it. There's, in a long bone in particular, the bone is changing constantly. That's the job of the endosteum, but the actual growth of the bone would be at the epiphyseal plate. In other words, the growth as if you were growing larger. But remember, there's a difference between growing larger and just changing out old bone for new bone. And those are the two things that they're getting at here that you need to answer. So if you answered anything like that, you got this one right. All right, so now let's go to what's next on the on our sheet. Let me bring this down. And on our sheet, we now have what is the function of each of the following items in bones? So this is relatively simple. Vitamin D, red marrow, appositional growth. So we'll start with calcium salts. Of course, calcium, what do you think calcium's going to do? So let's see if we get anything. They don't have that term in here, but we can find calcium. We can do an edit and search or find, and we can call calcium salts, and we can see what we find. Bone matrix consists of collagen fibers primarily formed from calcium salts. There you go, calcium salts. What's the function? It's required for the formation of organic ground substance and collagen fibers. All right, so you could easily say that. Now, where is it? It's going to be bone matrix. All right. You could go into whether or not it's in what type of osteogenic cells, like osteoblasts, osteocytes, etc. But generally, if you just say what's right here, you're in good shape. So that's a pretty easy one. So vitamin D. Now, what's the function in vitamin D? So let's go down here and let's search for vitamin D. So I'm going to type in vitamin. If you see down here, way down here, I have vitamin D, or D. All right. And it says mechanical stress stimulates the deposition of mineral salts and collagen fibers. In other words, for your bones to stay dense, you need to pound on them compact, to get them to activate and grow stronger. That's why astronauts, for instance, their bones kind of like just wither away. You actually have to get up and use your bones every day to actually cause this process to work. So it's called mechanical stress. Now, the predominant mineral in bone cannot be absorbed from the small intestine if vitamin D is lacking. So there you go. Vitamin D is needed. All right. So calcium can be absorbed from your food, more or less. Vitamin K supports the mineralization, may have synergistic role with vitamin D, you don't have to say that, but it's involved with the creation of bone, and without it you cannot, calcium cannot be absorbed. If calcium cannot be absorbed, then your bones aren't going to harden. They'll be wimpy. They're not going to grow, they're not going to harden. You're going to have soft bones. Now the red marrow, let's take and do that one. So if you search red marrow, let's see if we can find previous. All right, here we go. The hollow medullary cavity is filled with yellow marrow and runs the length of the diaphysis, so on the long bone. It's the inner part of the long bone. The walls of the diaphysis are compact bone. That's the hard stuff. All right. The epiphysis are wider sections on each end of the bone. Diaphysis, the epiphyses. All right. Epiphysis are the wider sections at the end of the bone, and are filled with spongy bone and red marrow. All right. So red marrow is in spongy bone. Something to remember, all right, but we still didn't get its function. What is the function of red marrow? All right, now the red is a hint. I'm going to tell you that, and let's go use previous on that one. Connective tissue interior of a bone where hematopoiesis takes place. What is hematopoiesis? Well, hemato is blood, and this is creation. So this is where you make red blood cells. So red marrow is where red blood cells are in. So that's the proper function. Now, we can look for appositional growth. Let's see what that is. Do they have that in here? No, I'm going to have to search for it. Let's come down here, and let's go appositional. I think we can get by with just appositional. A-P-P-O. Appositional growth. And it goes, this is called appositional growth. So right here, while bones are increasing in length, they are also increasing in diameter. Growth and diameter continue even after longitudinal growth. Now this can happen when you put weight on your bones. They get thicker. Now they're not going to grow longer after a certain age, but they certainly can grow thicker. All right. They're not going to grow longer unless you break one and then they grow together. So the appositional growth here is when they grow thicker. So that's what it means. And what is it? It strengthens your bone. The function is they grow thicker because you're putting stress on them. You're walking around, you're carrying things, you gain weight, so certain bones will get thicker, they get greater structural strength. So that's your answer on appositional growth. So now we have gone through these two tables, and now we have this here. What type of bone or term am I describing in each case? So we'll need to go and look at the type of marking or description for these, so we can get these terms down. Let me see, what else do we have to do? Oh, we have the types of fractures. Then we'll come back to that. The types of growth there. Describe the negative feedback that controls. Okay, we'll have to go through that, and then we'll be done here. So, okay, let's go and find these. These are going to be on a diagram or chart somewhere, and I just saw it not long before I started this video, so let's go see if we can do that. We need a what's the first one we need? We need projection round. Okay, there's a table somewhere in the book here that has all of these. Let's see if I can find it quickly. I'm just scrolling it. By the way, you definitely should know the difference between an osteocyte and an osteoclast. Osteoblasts and osteogenic cells. So bone cells, make sure you know the bone cells on the exam. Here we go. All right, let's see if we can find something like this in our descriptions. Is this what we're looking for? A rounded articular projection, a round or oval opening, a large rounded rough projection, and a canal-like passageway. So let's see if we can find some of these. A rounded articular projection. Do we have anything like that? A rounded surface. All right, not a projection. A projection is going to be sticking out. A rough surface. All right. An opening into a canal. Let's see, what do we have here? Let's see. Let's pull these up at the same time and see if we can find a large rounded rough projection. Alright, a large rounded rough projection. Let's see, they're using slightly different terms. Rounded surface, might be a condyle, alright, but it says rounded projection. So where two bones meet, a rounded surface, a sharp process, a small rounded process. Alright, does that sound like? No. This is a rounded articular projection. Well, unfortunately, these are not as useful as you might think. Alright, so let's see if we can find something else that might help us with these. There's articular. Small, cube-like, cylindrical. These are the bone classifications. And we are at the beginning of the thing. So what I'm going to do is I'm going to see if we can find articular projection in the book. Alright, and it's searching, and I guess maybe it's searching the whole book. It's giving me, maybe my computer has slowed down here for some reason. Nope, it says we do not find this term. So, what can we do? Well, let's go back to the internet. All right, so we actually want a rounded articular projection. The head. All right, so a rounded articular, the whole idea here is what is articulation. All right, articulation. All right, articulation. Let's find out what that means. What does it mean to have an articulation? All right, the French of clear, distinct sound. Nope, that's not it. So it's something having to do with bones, not that. So let's do this. All right, here we go. So a joint, also known as articulations, are formed of a connection between bones. So an articulation, all right, is part of the bone that forms a joint. So a large, rounded articulation, like the end of our bone here. All right, so large, rounded articulations. Let's go back. A rounded articular projection. So it also means a projection. So it's articular, rounded, part of a joint, all right, and it's rounded, so projection. So keep that in mind. So what is that thing? If we look through our list, what type of bone term is this thing? All right, we look through and we're going to look for something that's part of a joint. All right, maybe part of a long bone that makes a joint. Flat bone, size bone, long. Nope, not here. So maybe there's articular cartilage, but we want an articular projection. What are we calling this piece? All right, that's essentially whatever. So here's again, articular cartilage. All right, what do we call that type of marking? Articulations, where two bones meet, okay? But what is a projected articulation? So we keep looking. Any of these, a ridge, a hole, a small pit, a groove. All right, well, here we go. Now, each of these terms here, realize there's something going on here. So we have lots of things to learn on this one. We have this thing called a fovea capitis, the head, the tubercle, the sulcus. Sulcus is going to be a groove. The condyle. Which of these, a facet? Which of these things is this thing we're talking about? Which one are the best? Which is the best answer to this? And actually, you know, our book really doesn't give you a good answer. It's like this piece right here, but what is that? All right, well, that's the head of the bone. All right, and if you said that, the rounded articular progression, that would be true for that particular bone, but is that the best answer? Let's go back and let's see. How about a tubercle? All right, what is a tubercle? All right, let's go look and see if we can find tubercle in the thing. A small rounded process. Does it say small? Well, it's a rounded, but then you go, well, what is a process then? Is a process an articular projection? What is an articular projection? And yeah, we're gonna roughly say the tubercle is a rounded process. Okay, that would be a small one. The head would be a larger one, like the head of the femur. So if you gave me either of those, I would probably be okay with it. But I'm just saying that it's not as easy as they say it is. But now our rounded oval opening, that might be easier to find than that one. All right, let's go look. A hole through a bone, maybe a foramen. But it does say rounded, doesn't it? A round or oval opening in a bone. Certainly here's a passage, but that's canal. That's not an opening. But a hole, all right, that sounds pretty good, like a foramen. All right, is there anything else that is a hole in a bone? Do you see anything that is a hole in a bone? A groove, all right, that's a sulcus. I kind of let you know that. An opening into a canal could be a meatus, but that's into a canal. But a hole through a bone is a foramen. So if that's the only part of it, it says a round or oval opening into a bone. Doesn't mean a hole. So the question is, an opening, is that the same as a hole? No. But a canal passageway, all right, we're going to go back. We're going to look at this. A slit, all right, now that's a fissure, but a hole. This is the only thing that kind of sounds like it would be rounded, all right? So you can call it a foramen. Holes are holes, of course, but they say that's a foramen, right? Through which blood vessels can pass. So, yeah, we'll go with foramen. Now, the next one is a large, rounded, rough projection. So let's see if we can go for our list. Do we see rough anywhere? A rough surface, all right? So a tuberosity, it's rough. I don't see anything on here that says rough. And so that's your clue that you can call that a tuberosity, all right? It's a rough surface. But of course, they did say, what? A large, rounded, rough projection. Okay? But yes, that'll work. All right, so canal-like passageway. So let's see if we can find anything that looks here like a canal. Well, here's a canal. So let's see. A protrusion, raises the surface, flat surface. Yeah, there's nothing else but canals here. There's auditory canal as an example. It's a passage through a bone. All right. Is there any other term, though, that would fit here? Canal-like passageway. There's an opening into a canal. None of these look good unless you just use the term canal. So maybe we should look up something. All right, so let's go and let's look for bones. Let's do a search. Canal-like passage in a bone. A meatus, all right? It's a tube or a channel. Now, we already looked at that, and I actually mentioned it there. So it says the opening into it, but it is the opening into the canal. So the meatus would be your answer in that one. All right. Now, describe the comminuted, the green stick, and the compression fracture. I have a hard time saying comminuted. Well, that one. And we'll do that, and that's pretty easy. The others can be difficult if you're looking through the book for these things. Different books, different hospitals, different places you go, we use different names for things. It's just the nature of the beast. So let's go look at these. describe how these differ from one another. So this is pretty straightforward in the book. You're just going to have to go and look at these broken bones and describe them. And I really can't help you much here other than you go through and let's see, where is it? It's further down. We have the pictures and they describe it pretty well. It's also in the PowerPoints. So let's go down here to well, I certainly thought it was sooner than this, but I guess not. Here we go. Close. You do need to know these. So open, close, transverse, spiral. Here's your green stick. Green stick is like you chopped a little piece out of it. All right, so that's an easy one. It's just like you were trying to cut down a tree and you chop at an angle above and an angle below, and you just chopped a piece out of the stick. Think of it that way. All right, so that's a green stick, and you can describe that however you like. The one I can't pronounce here is like you shattered glass. It's like you shattered the windshield and you got lots of little pieces shattered all the way through, but they're all still kind of in place. All right, so it's like you banged something on the side and it shattered pieces like that. Now the impacted is like a crack. All right, so let's see, which ones were we? The compression is the other one we're looking for. So the compression, fracture, they're not using the same terms. They're not. No, they're not. Transverse, basic repair. So one stick ring impacted. One is driven into the other. So here impacted, compacted. One fragment is driven into the other. So let's see if we have that. Yes. So you're going to say compacted instead of impacted. Essentially the same. It's like a crack. Okay. Let's see. Next question. Kyphosis, scoliosis, and lordosis. I went through that. That's in the PowerPoints, and that has to do, of course, with the spine and how it curves. So in this book, we can just look up, let's say the one that's easiest is scoliosis. You can find it. All right. Excessive posterior curvature of the thoracic region. Lordosis, excessive curvature of the lumbar region. So basically it's twisting at various regions of the spinal column. So let's see. We saw some pictures of that in the PowerPoints. You should be able to get that, but here are your written definitions: kyphosis, scoliosis, and lordosis. And if you say these things, that's fine. If you want to say them in your here we go. So this is scoliosis. You can see it that way. Here, kyphosis is skewed that way, and this one's down here. All right, lordosis here. So it looks like lordosis comes with pregnancy. That's what they're giving me the impression of. But here are your you can also use these definitions, or you can combine them. All right, so notice that scoliosis is lateral. So lateral means like this, back and forth. So that one's a little different than the others. All right. And these are normal curvatures, but they're excessive. So that's the way you can think of this. So you can use either the definitions above combined maybe with the ones below there. The thing is, scoliosis isn't an abnormal lateral curvature, all right, or a twisting by the column. These are just excessive the normal curvature. All right, so that should give you that one. Let's see, and describe the feedback reaction that controls blood calcium levels. All right, and so for that in the book, blood calcium. Let's try that. I'm going to say blood calcium and see if we find anything. Blood calcium levels, and so here we go. This is where you would go here, and examples of hormones that use the CAMP as a second measure include calcitonin, which is important for bone construction and regulation of calcium levels, glucagon, which plays a role in blood glucose. All right, so they're talking about something called phosphorylation, which we did not have time to go into. But let's see here. It's asking describe negative feedback reaction that controls blood calcium levels. All right. It's in bone construction, so it's going to be in the bone chapter. What this is doing is telling us, oh, blood calcium levels are regulated here, so we need to go and find this somewhere in the bone level. Let's see if we can go edit, and we can find next. All right, calcitonin is released in response to the rise in blood calcium levels. It appears to have a function of decreasing calcium concentration. So here you go. Here's your answer, calcitonin. All right, talk about calcitonin and how it works, and you have the correct answer. All right, calcitonin reduces blood calcium levels. Now, the thing is, it's a feedback system, so what happens? It appears... what functions decrease calcium levels by making calcitonin? Well, these would be the things that would do this and how you regulate it. So read through this and you should get the answer, and that would be how it regulates the blood calcium levels here. And this is on page 684 and 685, so you'll need to read that. All right, and basically you just essentially these functions are not maintaining, so the importance of calcitonin is not entirely understood. Let's see if we can help. So when calcium levels get low, when they get too high, I guess you would release calcitonin. So in other words, when calcium is low, all right, you release, when calcium is too high, you release calcitonin, which would reduce blood calcium levels. And then how does it really decrease them? It decreases them by what? Making more bone, all right? You basically make more bone when your calcium levels get too high. If your calcium levels get too low, it goes the other way, all right? But that's essentially a feedback loop. And calcitonin is the center part to that. You can look up more. You can do a simple search on calcitonin on YouTube, on Google, and you'll get probably a far better explanation there. But that's essentially what you need to talk. If you mention calcitonin in here, you're probably going to get it pretty much right if you have some mention of calcitonin and what it does. All right.